Okay guys, so here's what we're going to do. This is a reshoot of a video on some Newmans and cyclohexanes. But first let's go ahead and talk about Newman projections again. To remind us, we can look at Newman projections of alkanes and acyclic molecules, and typically it's done not down the 1,2 but the 2,3 bond. So here I have a model of butane. I don't have as many, I'm out of hydrogens, that's what the little white balls are. But let's go ahead and look at this. So let's look at butane down the 2,3 bond. So here's carbon 1, 2, 3. So 2, 3. Here I am looking down the 2,3 bond. You might want to turn the brightness up on this. It's a little dim in my office right now. Okay, so here's our anti-conformation. Notice, look at the side, we look straight on. My two largest groups, this one and this one, are as far apart from each other as physically possible. Now let's just rotate the back carbon 60 degrees. Okay. I'm eclipsed. So notice here, my two big groups, or not my two big groups, my two groups are eclipsed from each other. They're right on top of each other. Now let's rotate it again. Now I'm gauche. I'm not eclipsed. I'm actually, here's my first group, here's my second one. They're gauche, that's off to the side. So notice they can contact each other a little bit, but it's not what's about to happen next. What happens next is eclipsed. Here, in this case, my two largest groups are right on top of each other. So notice, yeah, here they are from the side. They're right. This conformation is my least stable because my two biggest groups are right across from each other. They're bumping into each other. Okay, and then we rotate it again. Now we're gauche again. Here's my, I notice I'm keeping my hands on my two large groups. Then we go eclipsed. And now we're back to anti. So let's just one more rotation real quick to make sure that we follow what's going on. So okay, here is our anti-conformation where my two big groups are as far away from each other as possible. This is my most stable. Then I rotate, eclipsed, staggered, eclipsed. Notice they're right on top of each other. Here's the side view. Here's another view. Staggered, eclipsed, and back to anti. So okay, that was Newman projections. If you have any questions or want to come use the model, feel free to do so at any time. Alright, so now let's talk about cyclohexane for a while. Okay, I have a model here. At the moment, my red hydrogens are axial, or the red balls. The green balls are equatorial. Notice how the axials are sticking either straight up, in the case of these three, or straight down in the case of this three. So okay, as I said, chair flip, we grab the end. So here's my carbon 1, here's my carbon 4. I'm going to pull up. So now here's the boat that I talked about, and then pull this one back down. So as I said, what axial becomes equatorial and equatorial becomes axial. Let's take a moment to confirm that this was the case. Okay, so as I said previously, the red balls were axial. Now, the green balls are axial. Let's look at the green. So I have green 1, 2, 3 sticking up, and then I have 1, 2, 3 greens pointed down. So those are now axial. They used to be equatorial. The red ones are equatorial. They're sticking out. Oh, where'd my carbons go? Dope. Where'd they go? Okay. Red axial. Green axial. A couple of my carbons aren't rotating as well because this model kit is about 18 years old. So okay, one more chair. Flip we go. Okay, green axial. Red axial. Okay, it flipped that time. Alright, so that may have been a little tricky to see, but let's go ahead and just stick a big group on there and let's see what we can get. And let's look a little bit more at 1,3 interactions. So I'm going to go ahead and put a group on the corner here. So if we look, the group is, okay, so I'll point it at you guys. Point the camera here. Here's my 1, here's my 4. This group is equatorial. It's out of the way. It's not ideal because we could still have a few interactions if I were to put the chair into a Newman, but that's beyond what I want to do. Alright, so let's do a chair flip. Notice right now it's equatorial. So I flip. Now it's axial. So I had talked a little bit about 1,3 interactions. Here's what's going. So carbon 1 is where my substituent is. So 2, 3. So here's a 1,3. And here is a 1,3. So let's rotate it over here. Let it bump into that. So notice these two carbons that I have my hands on right now are where the 1,3 interactions are when an R group is in an axial position. And the 1,3 interactions get even worse when there's other groups there. So let's do another chair flip so you can see. By the way, with this model, what you do is you pick a carbon to be 1 and 4 and then you flip. So okay, said my molecules are not keeping their perfect chair because they're bent funny or old. So okay, I'm flipped. So I grab, here's my corner carbons, flip, notice my group is equatorial, sticking straight out at you. So now if I do my chair flip, it flips axial. Interactions, equatorial, axial. Again, I'm discussing the position of the R group. And it's a little exaggerated, so it seems to be bumping into the 4, but it doesn't do that, I promise. So then we flip. Now I'm equatorial, axial, and on and on and on we go. Okay, hopefully that was instructive. If you have any more questions or anything, feel free to ask in class, or you are always more than welcome to stop by. That is all for this edition.